Thank you so much for watching this video. Today I'm going to talk about deep neural networks and kernel machines. My talk is going to divide it into these 5 parts. Let's start with the first part. Deep neural network is a very powerful machine. It achieves a great deal since being invented, also in a lot of areas. For example, image recognizing, recommendation system, and so on. Also, there is a theory, universal approximation theory, to back it up, which turned out deep neural network is indeed a very great machine in machine learning. So now let's look at the deep neural network. Here is the formula of the deep neural network. In this formula, we can see this phi is the activation function, W is the weight. In this slide shows the structure of deep neural network, which include input layer, hidden layers, and output layer. Hidden layers can go very deep and also can add a lot of neurons in each layer. Another very important part of deep neural network is activation function. In here, I list 3 kinds of activation function, which in this research we are going to use ReLU activation function. Speak of kernel machine. Kernel can do classification and regression too. Also, in here, I list a binary classification kernel machine. In this machine, you can see this KXI is the kernel, and omega I is the weight, and Y is the binary data. So kernel function is a very important part of kernel machine, and in this research we are going to use polynomial kernel, Gaussian kernel, and another one is linear kernel. So about the experimental setting up, in this research we are going to compare 5 machines, which are Gaussian process, support vector machine with 3 kinds of kernel, and also deep neural network. And in the simulation data, we have 6 of regression simulation data and 5 of classification data. And we also have 10 real-world regression data and 16 real-world classification data, which include binary classification and multi-classification data. And for each data set, we are going to divide the data into 70% and 30%. And also we normalize the data before we run the machine, and for each data set we run 50 times on each machine. And also we are going to compare the mean square error for the regression data set and accuracy for the classification data set. The question we want to ask here is deep neural network going to outperform among 5 machines? Also, another very important theory in this research is no free lunch theory. It simply states a given learning technique is good, but also has its limitations. Since deep neural network is a very great machine, the question we want to ask here is, does deep neural network enjoy the free lunch? So let's look at the simulation starting. First, here is how we simulate the regression data. There will be 25 variables, and here is the parameters beta. And this table shows 6 sets of simulation regression data. We simply enlarge n from 25 to 1250, and there will be 6 of them. And here is the results. The blue line is the deep neural network mean square error, and this is the mean of the 50-time mean square error. This is the median of the 50-time mean square error plot. And in here we can see the blue line is above this support vector machine with kernels. So, which means the support vector machines are working very well in this for this data sets. And also we can see in here when we increase the sample size from here to here, and then the mean square error getting a lot of smaller for the support vector machines. And then when we increase from here to here, you can see the deep neural network keep getting better and getting better, and Gaussian process is catching up from here with the deep neural network and start to getting better, outperform deep neural network. And this is our simulation classification data. We have 5 sets of them, which we simply increase the sample size from 25 to 500. And we have 100 variables which are generated from multi-Gaussian distribution. And in here, these two plots shows the results, and this green line is the support vector machine with linear kernel. We can see it's working very well for this classification problem, and the blue line is the deep neural network. You can see it's increasing, keep increasing until we have kappa equal 1/1. In the medium, it's increasing to 1/2 and then start to getting better. And for the Gaussian process is keep getting better, eventually catching up here. So for the regression data set, there are 10 sets of them. And then this is the median mean square error table. In this table, we can see support vector machine with Gaussian kernel win 6 times, and deep neural network didn't win in this table. Gaussian process won twice. Here is the mean table. Mean table, the winner is still support vector machine with Gaussian kernel, and unfortunately, deep neural network didn't win. And here is the box plot. Based on this box plot, we can see deep neural network is always have a larger range than the support vector machine. But in this one, it seems a little bit better than the support vector machine with polynomial kernel, and definitely better than the Gaussian process. But in these ones, we can see the performance of DNN is really not very good. Here is the classification data. There are 9 of them for the binary classification, and here 3 of them for the multi-classification, and these 4 data we want to test a special case, test this parameter kappa. Here is the binary classification results. This is the medium ACC table. So in this table, we can see the Gaussian process win 3 times, support vector machine with polynomial kernel win 3 times, deep neural network didn't win. And in the mean table, deep neural network win once, but this time he tied with the support vector machine with Gaussian kernel and the polynomial kernel. And support vector machine with polynomial kernel win 4 times in this table. And here is the box plot. Compared to the regression results, we can say deep neural network is definitely doing a better job among this binary classification data. And also, it's very comparable with other machines, have a relative smaller range. And here's the multi-classification results. And the support vector machine with Gaussian kernel win 3 times in this medium table. And in the mean table, support vector machine with Gaussian kernel win 3 times, deep neural network didn't win. And here is the box plot. This 4 data set is we want to test a function over kappa, and we just simply enlarge the sample size. And here is the box plot results. In this box plot, we can clearly see deep neural network is getting better and better when we enlarge the sample size, because here you can see it has a very large range, and then the medium is a lot of far from the better machines, but it start catching up eventually, like perform as good, almost as good as the support vector machine with this kernels. And here is the plots of the results, and we can see similar as the box plots shows, it's keep catching up. Here shows very much, even though start with really bad, but it's keep catching up, and when you enlarge the sample size. So basically, based on these experimental results, we can answer our 2 questions. Deep neural network is now outperform among the 5 machines, and also deep neural network is very greedy. It needs a lot of data point to have a better performance. Thank you so much.